All right, how big on number 3 is segment AB right here? 6.9. We have a congruence mark here that is mirrored over here on BC. So AB is 6.9. What about angle BDA? So we go from B down to D and then up to A. So this angle right here is the one we're looking for. How big is that angle? 30 degrees. It is congruent to this angle right over here because that long diagonal is bisecting the angle. So the measurement of angle BDA is 30 degrees. On number 4, what is the measurement of segment EH right here? 3.7 has a congruence mark for GH, so it is the same size. So EH is 3.7. And then what about angle EJF? How big is that angle? 90 degrees. Because those diagonals are perpendicular with each other. All right, I want to spend the rest of our time together today going over any questions that you guys might have about the Module 7 test review. If you need another copy of the test review, it's over here in this red organizer, second paper up. Very bottom paper is the warm-up page for this week. The one right above that is the test review. So go ahead and pull your test reviews out and let me know which problems you guys would like me to go over. Yes. Number 3? Absolutely. So we want to find the value of x in this diagram. Each of these angles that it has marked here for us, these are all exterior angles. And if you don't have this written down somewhere in your notes or elsewhere, the sum of the exterior angles of a polygon is always going to be 360 degrees. So we're going to take these angles. We've got, looks like 6 of them. 1, 2, 3, 4, 5, 6 angles. We're going to add them up and set them equal to 360 degrees. So I have x plus 6. There's one of my angles. Plus x plus 18. There's a second angle. Plus 61 degrees. There's a third angle. Plus 47 degrees. There's a fourth angle. Plus x plus 22. There's a fifth angle. And then the sixth angle here would be 2x plus 1. No matter how many angles that polygon has, if we want the sum of the exterior angles, it will always add up to 360. All right, now we need to combine our like terms together, so we're going to combine our variables first. So I have 1x, 2x, 3x, 4, 5x's. So 5x plus, and now we'll go and add the constants. 6 plus 18 plus 61 plus 47 plus 22 plus 1. Let's see, 6 and 18, that's 24. Plus 61 is 85. 132 154, I think it's 155. Can somebody double check me on that? I think when we add up all the constants, it's 155. Yeah, okay. So 5x plus 155 equals 360. And then we subtract 155 from both sides. So then I have 5x on the left, and on the right I have 205. And then we divide both sides by 5. 201 divided by 5 is 41, so x is 41. What else would you guys like to see? Number 10? Absolutely. Number 10, given the diagonals of a rhombus are 16 meters and 30 meters long, what is the perimeter of the rhombus? So I'm going to draw a rhombus first. What do we know about the four sides of a rhombus? They are congruent, so all four sides are the same size. So I'm going to do my best to draw a shape where all four sides are the same. And it's giving me the lengths of the diagonals. So I'm going to go ahead and draw those diagonals in as well. Because it's a rhombus, I know these sides are all congruent. Because a rhombus is a special type of parallelogram, I know that my diagonals are being bisected. And I know that right here where the diagonals are crossing each other, it's forming four right angles. It says one of the diagonals is 16 meters. So let's go ahead and make that this diagonal right here. If this is my 16-meter diagonal, then how big is each section on that diagonal? 8. So I have 8 and 8. And then the other diagonal, it says, is 30 meters long. So how big are the two sections of that diagonal? 15 and 15, yes. We need to find the length of one side of this rhombus, because once I know one side, I know all the sides. So I'm looking right here at a right triangle, and I'm going to use the Pythagorean theorem to solve this. So I have a squared plus b squared equals c squared. We're looking for the hypotenuse because that is opposite my right angle. So the c is going to stay c. The 8 and the 15 go in for either a or b, doesn't matter which is which. So I'm going to take the 8 and square it, plus, and then we take the 15 and square it, set that equal to c squared. 8 squared is 64. What is 15 squared? 225. Then we add 64 and 225 together, and we get 289. And then we have to take the square root of both sides. On the right, the squared and the square root cancel each other out. What is the square root of 289? 17. So that's not the answer to my question, but now I know that each of these sides is 17. And so to find the perimeter, we're going to add all four of those sides together, but they are all congruent. So I'm adding the same number 4 times, so I can do 4 times 17. And 4 times 17 gives me 68, so this would be 68 meters. Yes?
For the square root on this, do we have to show our work?
like how you simplify it. If it comes out to be a whole number, no. If you're putting it in its decimal form, then no. But if you're writing it as a reduced radical, if the directions say that you need to write it in its reduced radical form, then I would need to see your work for how you're arriving at that. Yep, good questions. Yes? If you have to find the perimeter as well, so say it wanted you to find the length of one of these sides and it said to put it in reduced radical form, but then it also wanted the perimeter, something like that. For the perimeter, you would have to take your side and change it into its decimal form and then add all your sides together. But for the side length itself, if it said it wanted that in reduced radical form, then you would show me you're simplifying for that part. But for the perimeter part, always decimal form for that one. What else would you guys like to see? Yes? Number 6, part B? Absolutely. All right, so we have a rhombus. Since I know I have a rhombus, I'm going to go ahead and mark it up with that information. That means all 4 of my sides are congruent. Means my diagonals are being bisected. Means I have 4 right angles right here where the diagonals are crossing. And my diagonals are bisecting the angles that they're cutting. So here, this 18 degrees, that is congruent to the little half down here. So this would also be 18 degrees. And because this is a special type of parallelogram, opposite angles are congruent. So these 2 little halves over here would also be 18 degrees and 18 degrees. Bless you. DMN and RMN, these 2 halves up here, that angle is being bisected. So while I don't know that size, I know they're congruent. And the same thing is true down here for DCN and RCN. Those are congruent. It tells me that MD is 20, which is marked right here on my picture. And MC, this diagonal right here, is 24. So since that diagonal is being bisected, each of those halves there would be 12, because that is half of 24. All right, now let's get down into the questions. We need to find the measurement of angle RNC. RNC, this angle right here. Well, that is a 90-degree angle. Then we want the measurement of angle DRC. DRC, this angle right here. That is the same size as MDN right here, so that is 18 degrees. Angle NMR. NMR. This angle right here. We don't have the size of that angle. But what I do have is this triangle right here. That is a right triangle. And so I know it has a 90-degree angle, and then I also know it has that 18-degree angle up there. So I can take that information. I can say 90 degrees plus 18 degrees plus the measurement of angle NMR. And that would be equal to 180 degrees. So I add the 90 and the 18 together. That gives me 108 degrees. And then I can subtract that from both sides. Give myself a little bit of room here. So I subtract 108 degrees from each side. And that means the measurement of angle NMR is 72 degrees. So I'm going to go ahead and add that to my picture now too. This angle here is 72 degrees, so that means on the other side that is also 72. And down at the bottom of the rhombus, both of those angles down there are 72 degrees. The measurement of angle DCR. DCR. So I want this whole angle right here. I would add 72 plus 72. And I get 144 degrees for that. So I'm putting those two smaller angles together to get DCR. Then we want the measurement of segment DN. This segment right here. So again, I'm going to look at a right triangle. I'm looking at this right triangle right here. And I'm going to use Pythagorean theorem. Now this time, this is my hypotenuse right here. So I do a squared plus b squared equals c squared. The 20 is my hypotenuse, so that goes in for c. So I have 20 squared. This side mn is 12, because that was half of that diagonal, so I have 12 squared. And then the segment that I'm looking for, dn. So dn squared. 12 squared is 144, plus dn squared is equal to 20 squared is 400. So then I subtract 144 from both sides. That means that dn squared is equal to 256. And then we square root both sides. What is the square root of 256? $16. So dn is 16. And then the last thing they asked me to find on this problem is dr. Well, if dn is 16, how would I find the length of dr? Multiply 16 by 2. Which would give me 32. What else would you guys like to see? Yes. For the whole thing, then we would have, like, if the whole thing MC was 7, then this would be 3.5 and this would be 3.5. So you'll have decimals for your segments then, if it's an odd number. Good question. What else would you guys like to see from the review? Number 5? Absolutely. We need to find the value of each variable in this parallelogram. Let's go ahead and start with y. I know I'm working with a parallelogram, so that means I know opposite sides are congruent. And I know opposite angles are congruent. So to find the measurement of y, I know that GH is congruent to JI. So the measurement of GH is equal to the measurement of JI. So 2y plus 2 is equal to 3y minus 9. Next thing I want to do is get my y's to the same side. So I'm going to subtract 2y from both sides. So I would have 2 equals 3y minus 2y is 1y. So that would be y minus 9. And then I add 9 to both sides to get the y all by itself. And I get that 11 is equal to y. So that's my answer for y. Then we need to find A and B. Well, when I look here, I have only one A, and I don't know how big any of the angles are, except I do know this one. What's the relationship between this angle here and this 81? They are supplementary. They are consecutive angles, and so they are supplementary. So I can take 4A minus 21 plus 81 and set it equal to 180. The measurement of angle I plus the measurement of angle J is equal to 180 degrees. So 4A minus 21 plus 81 equals 180. Combine our like terms together here. Negative 21 and 81 would be 60. So I have 4A plus 60 equals 180. Then we subtract 60 from both sides. That gives me 4A is equal to 120. Then we divide both sides by 4, and I get that A is 30. To find B, what is the relationship between these two angles? What is the relationship between H and J? They're congruent. So angle H is congruent to angle J. That means the measurement of angle H is equal to the measurement of angle J. Angle H is B plus 78. Angle J is 81. So to get B all by itself, I need to subtract 78 from both sides. And that means that B is 3. Now we need to find the measurement of angle I, and we need to find the length of GJ. Well, to find the length of angle I, or the measurement of angle I is 4A minus 21. We figured out that A was 30, so I have 4 times 30 minus 21. 4 times 30 is 120. 120 minus 21 is 99. So I have 99 degrees for the measurement of angle I. And then for GJ, GJ is congruent to HI. So the measurement of GJ is equal to the measurement of HI. HI is y plus 4. And we figured out at the beginning that y is 11, so I do 11 plus 4, which gives me 15. So 15 for GJ. What other problems would you guys like to see me go over? Number 9? Absolutely. Quadrilateral KITE is a kite. Find the length of TE, then find the perimeter of the kite. So this is the first thing we're going to find here. In a kite, one of my diagonals is being bisected. Well, I know that that's not diagonal KT because I have the two measurements of that. So diagonal IE is the one that's being bisected. So SE down here at the bottom would also be 18. Because this is a kite where my diagonals intersect each other, it is forming 4 right angles because they are perpendicular to each other. So I can look at this right triangle right here, and I can use the Pythagorean theorem to help me find the length of TE. So a squared plus b squared equals c squared. What we're looking for, TE, is my hypotenuse. So I'm going to replace c with TE, so that becomes TE squared. I put 18 in for either A or B. I put 42 in for the other one. And now I have to square both of those. 18 squared is 324. 42 squared is 1,764. So then we add 324 and 1764 together. We get 2,088 is equal to TE squared. Square root both sides to get TE by itself. On the right, the squared and the square root cancel. The square root of 2,088, if you write it in its reduced radical form, is 6 square root of 58. Or you could write that in its decimal form. The directions did not specify. Decimal form would be 45.695 if you take that out to 3 decimal places. So again, because the directions did not specify which way you were supposed to give your answer, either one of those would receive full credit. Yes?
694.
Yes. Yeah, if you have 694, that would be fine. All right, then we're supposed to find the perimeter of the kite, so I'm going to have to add all the sides together. But as it stands right now, I know TE, and I know that that would be congruent to IT up here, because this is a kite. I don't have the length of KI or KE, but I know those are congruent, so I can use Pythagorean theorem again. A squared plus b squared equals c squared. Ki and Ke are both hypotenuses, so I'm going to go ahead and go with Ki. And I am looking now at this right triangle. I know one of the sides of that right triangle is 18, and the other one is 20, so I have 18 squared plus 20 squared equals Ki squared. We already found that 18 squared was 324. 20 squared is 400. So then we add 324 and 400 together. That would be 724 is equal to Ki squared. And then we take the square root of both sides. Squared and square root cancel out on the right. And the square root of 724 in its reduced radical form is 2 square root of 181. In its decimal form, that would be 26.907. So this is the form that I'm going to use to find the perimeter. I have two sides that are 45.695. And I have two sides that are 26.907. I'm going to add those two to my picture. All right, so I multiply each of those by 2. 45.695 times 2 is 91.39. And 2 times 26.907 is 53.814. So when we add those together, we get the perimeter of the whole kite, which is about 145.204. Depending on how you round, you might get 145.2 or anywhere in between 145.2 and 0.204. What else would you guys like to see from the review? Number 8? Absolutely. Number 8, we have an isosceles trapezoid. So before I get any further at all, I'm going to go ahead and mark up my picture with what I know. There we are. So isosceles trapezoid, that means my bases, AD and BC, are parallel, and my legs, AB and DC, are congruent. First thing they ask me to do on this problem, though, is to draw in the mid-segment KL. That doesn't tell me which side K is on and which side L is on. So I'm going to put K over here on side AB. Since it's the midpoint, that means it's splitting this leg into 2 congruent parts. And L would be doing the same thing to the other leg. Again, splitting that leg into 2 congruent parts. And because DC was the same size as AB to begin with, all 4 of those little segments are congruent to each other. So here's my mid segment. They tell me that KL is 9H minus 4. They tell me that right here. We have that BC is 7H plus 12. So down here, 7H plus 12. And then AD is 3H plus 34. So up at the top, 3H plus 34. They want me to find H and the length of KL, so I have to use my mid-segment formula. The mid-segment is equal to 1/2 times the sum of the bases, B1 plus B2. So in the place of mid-segment, I'm going to replace that with the length that we were given for KL, 9H minus 4. And that is equal to 1/2 times the sum of my 2 bases. Well, one of my bases is 3H plus 34. And the other base is 7H plus 12. First thing I want to do at this point is get rid of that fraction. So we're going to multiply both sides by the denominator. We're multiplying both sides by 2. So on the left, that's going to distribute. And I'm going to have 18H minus 8. On the right-hand side, my denominator cancels with the 2, and everything else stays the same. So I would have 3H plus 34 plus 7H plus 12. And then we combine our like terms together over on the right. So my left side drops straight down. On the right side, 3H and 7H gives me 10H. 34 and 12 gives me 46. I'm going to get my H's to the same side, so I'm going to subtract 10H from both sides. 18H minus 10H gives me 8H, so 8H minus 8 equals 46. Then I add 8 to both sides. I get 8h equals 54. Then I divide both sides by 8. And 54 divided by 8 is 6.75. So there's my value for H. Then I need to find KL. We have our expression for KL. KL is 9H minus 4. And we just found that H is 6.75. So 9 times 6.75 minus 4. When I multiply 9 and 6.75 together, I get 60.75. And then I subtract 4 from that. So KL is 56.75. And then we have a part C down at the bottom. Tells me the measurement of angle D is 99 degrees. Angles D and A are congruent because those are base angles. Tells me the measurement of angle C is 5n plus 31. Well, angle C is a base angle with angle B. So angle B would also be 5n plus 31 degrees. Angle A, because it's congruent to angle D, is 99 degrees. So I can come down here and answer the very last question. Angle A, we know, is 99 degrees because that's congruent to angle D. To find n, I have to make use of what I know about my non-base angles. Remember, the non-base angles, so A and B, are supplementary. So the measurement of angle A plus the measurement of angle B is equal to 180 degrees. Angle A is 99 degrees. Angle B is 5n plus 31. And that's going to be equal to 180. Over on the left, I'm going to combine my like terms together, the 99 and the 31. That would be 130. Then I subtract 130 from both sides. I get 5n is equal to 50. And then I divide both sides by 5. And I get that n is 10. Now I know that n is 10. I can find the measurement of angle B, because angle B is 5n plus 31 degrees. So I have 5 times 10 plus 31, which would be 50 plus 31. So the measurement of angle B is 81 degrees. All right. The bell is going to ring in 1 minute, so I want to show you guys where you can find the answer key that is already posted for you. It is in Canvas. You have to go to today's page and scroll all the way to the bottom. So I'm going to pull that up on the screen now. Don't forget, you're turning in your test review tomorrow when you come in to take the test.